Embark on a journey into the realm of digital twins, where virtual models meet real-world counterparts to revolutionize design, operation, and maintenance across various industries. In this episode, we'll explore the fascinating world of digital twins, examining their applications, benefits, and potential to transform sectors ranging from manufacturing and healthcare to urban planning and beyond. Digital twins are virtual representations of physical objects, processes, or systems that mirror their real-world counterparts in digital form. These virtual replicas are created using data collected from sensors, IoT devices, and other sources, combined with advanced analytics and simulation techniques, to provide insights into the behavior, performance, and condition of the corresponding physical entities. One of the key benefits of digital twins is their ability to simulate and analyze the behavior of complex systems in real time, enabling predictive maintenance, optimization, and decision-making. For example, in manufacturing, digital twins of production lines can simulate different operating scenarios, identify potential bottlenecks or inefficiencies, and optimize production schedules to maximize throughput and minimize downtime. In healthcare, digital twins of individual patients or organs can integrate data from medical sensors, imaging scans, and genetic tests to create personalized models that aid in diagnosis, treatment planning, and disease management. These patient-specific digital twins enable healthcare providers to tailor interventions to each individual's unique physiology and medical history, improving outcomes and reducing costs. Beyond manufacturing and healthcare, digital twins have applications in a wide range of industries and domains. In urban planning and smart cities, digital twins of entire cities or neighborhoods can simulate traffic flows, energy usage, and environmental conditions to optimize urban infrastructure, improve sustainability, and enhance quality of life for residents. In aerospace and defense, digital twins of aircraft, satellites, and military equipment can monitor performance, predict failures, and optimize maintenance schedules, ensuring mission readiness and operational efficiency. In energy and utilities, digital twins of power plants, grid systems, and renewable energy installations can optimize energy production, distribution, and consumption, reducing costs and environmental impact. The development and deployment of digital twins require interdisciplinary collaboration and integration of various technologies, including IoT, big data analytics, artificial intelligence, and cloud computing. Additionally, ensuring data security, privacy, and interoperability is essential to maximize the value and utility of digital twins across different industries and applications. Looking ahead, the future of digital twins holds tremendous promise. With ongoing advancements in sensor technology, connectivity, and data analytics, we can expect to see increasingly sophisticated and autonomous digital twins that provide deeper insights, predictive capabilities, and decision support across diverse domains. In conclusion, digital twins represent a powerful paradigm shift in how we design, operate, and maintain complex systems and infrastructure. By creating virtual replicas that mirror their physical counterparts, digital twins enable us to gain deeper insights, make more informed decisions, and optimize performance across a wide range of industries and applications. Thank you for joining us on this exploration of digital twins. As we continue to unlock the potential of this transformative technology, let's embrace the possibilities it offers for innovation, efficiency, and sustainability in the digital age.